Good evening, everyone. Welcome to today's class. Um, so I was mentioning the last class we did. We touched pandas a bit more, and we did more visualizations with Matplotlib, and we also, in line, we explored their documentations, how to find your way around errors when you are stuck, so when you're having encountering errors and you don't know what is coming from, especially if it's a probably an error that is showing like error, not like maybe you're writing and it's not giving the same output, so it's an error. So how to identify it, how to handle it. So we also went to documentations, when you're trying to explore a new feature, something you've not done before, right? So that's like a summary of what we did in the last class. So into this class, we are going to be dealing a bit with data cleaning. Yeah, I'll call it data cleaning. So I was mentioning that most of the data set you find on Kaggle, most, like I said, not all, most of the data set you find on Kaggle are usually data that have been cleaned, they have been worked on, they are not raw data in that sense. So in the real world, you're going to be encountering data sets that are not cleaned. You would have to do it yourself, you have to handle it. And in today's class, we're going to be doing more of that. So how to, where you get a data set, things to watch out for, especially when you need to clean the data, when it's very messy. So those are the things we'll be going through today. And I don't know, maybe I should not use Colab today. Maybe I should just use Jupyter Notebook on my system. So yes, also by the way, um, there might be a bit of difference when you're working with your Jupyter. For instance, me, I just have to open Jupyter Notebook on my system here. But for you, you might need to open Anaconda, then navigate to Jupyter Notebook, then open it. Then from there, you have something like this directory. Then you go to where you want to use your file. For me, I think I have it in documents, then IJAN, data analysis, then Python. Then I have the notebooks here. So for me, this is how I do it. Yeah. So for this class, we just open a new one. So the data sets that we're going to be working with today, I have them in Google Sheets. So I would have to um download it to my system. Usually, I can load it into Pandas directly, but it will require me to have another sorry it will require me to use another library, and I don't want to expose us to too much of those things. Yes, just let's focus on what we need to do, right? So this is the data set, so I'll just download it. This is going to be in XLX actually. Let me see. Okay, I can download it to CSV, but I'm not going to download the CSV. I'm going to download the XLX. So I want us to see how we can use pandas to open an Excel file. So it's downloading. Okay. So I think it should be in the download file. I think when I worked on this, I actually used Colab. Uh, okay, so we don't want to know where the file is on our system. So I could make that easy by just coming here. So it should be in my downloads, documents, downloads. I can't remember the name. Intermediates. That'll be high. So yeah, this is it. So I could just, um, so I need the directory. I can't see the directory from here, actually. So what I'll just do, I'll just go the normal way. Just come to downloads, check the file out. I think it's I. intermediates. Then I can copy the link. Okay, I think I can just press copy, and this should be automatic. It should be able to detect the file. So I'll just store it in parts, when we're dealing with variables. Oh yeah, it worked. Now we want to use pandas and of course when you're trying to do anything, you have to no we have to remember that um pandas and numpy is basic. So import pandas as pd, import numpy as np. So you see, yeah, that has imported. So here's my paths. So this is what I'm going to pass into. Now pandas does read, usually we do pandas does read csv, right? But in pandas, beyond pandas does csv. So if you use, I think control, oh not control tab, I think it's shift tab. Trying to remember. Okay, tab. So if you click on tab alone, it will give you the other options that are available. So for instance, here I'm here and I press tab, it will show me all the things that are possible with just pd. But what I'm actually interested in is read. So if I click it, as I continue, if I'm using csv, see it finish it up. I'm of like suggestions. So what I need here is excel, right? Then I open this and I pass this part. Usually I've put everything here into this place, but I don't want to do that. I just put this, since we know about variable, so why not use it and make it easier and clean. Now running this, I don't think it will just go ahead and run straight. Sometimes you need some other things to run with, and actually this is the first time I'm dealing with an excel with two sheets inside it, so I want to see how it will handle it. So okay, it came out right. Yep. So let's confirm. So here we have permit number to record ID. So inside the sheet here, we also have permit number to record ID. And what's the size of our data? That you need to scroll down. See, in Excel, you need to scroll down. In Python, you don't need to scroll down. So you can see 1.5. Sorry, I don't know if you can see this. I'm trying to maximize it. Zoom it in. Okay. My system is loading. I've zoomed already. If not over zoom. Okay. So we have 1536. That's 15,000. 365. So having 15,365, let's see if that's what we have here. So what we have here is also 15,364. That's from 0 to 1500. So it's the same count. So that works. But amazingly, sorry, the other sheet is not here. So what would I say happens? Is it I say you only pick the first sorry. So would I say pick the first sheet? So let me open this in um my system and see if see what's going on. So I guess it's only picking the first sheet. So that way you have to look into, so that way you probably have to look into how to access multiple sheets in Excel file. So it worked, but of course I'm sure there's also more to it. So I think if you want to check, you can just shift tab. So I think you can see, for instance, okay, look at it. So you have the read Excel file, then I think there's input and output, then the sheet name you actually want to read. So if you know the name of the sheet, you can pass it. So let's do something like loading both sheets in. I think these are other things that we really don't need right now. So let me see if there's an example here. Okay, in the sheet name, okay, there's an example here. So let's try to do this. So let's try to open a different sheet. So sheets, I think it's sheet underscore name equals, I'm not too sure, let me confirm. Yeah, sheet underscore name. So what's the other sheet name? I think it is inconsistent underscore data. So let's try that. So let's say inconsistent underscore data. Okay, so let's see if it's going to catch it. I think that one is a bit large, about, I don't think this one is that large. Okay, just 497. So it worked. So you can see, so I think from the way it works now is that it picks the default sheet, and the default one is the first one. So that was what happened, right? So I think you already understand how it works now. But for emphasis sake, I'm just going to put missing data there. So we're going to store this into inconsistent, more like set it inconsistent underscore data, right, into this, so that when you call inconsistent, it will be faster. Dot add, remember you want to do the first 5, so it will load it and store it into this place, so it won't take this much time again. Yeah, so we can see it now. Then we can do for the other one. I'll just copy this, then we'll do the same thing here. So this one is going to be missing underscore data, then we have missing here, and we also have missing here. So if you run this now, you should see the missing data. Come on, I think it's large, so it takes time. Okay, so here is it. So this is the missing data. So this is what we want to work on actually. So we want to undo data from there. We want to do our, we want to basically just understand what this data is and probably clean it. So this particular data, so you can see from the headers, from the column, like the column name. So if I want to bring the column out, I just call missing underscore data dot columns. So from the columns name, you can see that this is more of like for a construction company. It's more like a data set where they have different things: permit number, permit type, definition. So more of like maybe it's a construction company that handle construction for different areas, and they have a list of things they do. For instance, you have to write a proposal to maybe reconstruct a place. Then there's a lot of things to put in. For instance, I'm saying um number of existing stories, number of proposed stories. So that means it's like a proposal for a construction. There's estimated cost, there's revised costs, there's voluntary soft story retrofits, there's districts, there's location, there's there's permits, stuff like that, date, completed date, issue date, permit date. So I'm saying it's more of like I don't know any construction company in Nigeria, more of like a construction companies anyways that wants to, that deals in construction of, let's say, infrastructures. So this is more of like a data on that. So after this, the next thing you want to know is okay, the number of missing, maybe it's they're missing data or not, yes or no. Of course, you can look at it from the head and the tail. For instance, now we can see some places have NA, nan, nan, nan. That's not a number. NA means NAN. So anywhere you see NEN, sorry, NAN, it means not a number. So it means not a number. It's actually numpy. Yeah, it's a numpy uh, what's the attributes. for describing an empty value. So so if it is in NaN, then it's easier to handle. But let's just do a brief check on here. So if you check this part of it, okay, I think I'm at the bottom. Let me see if I can jump to the top. Sounds to reduce the size of this. So if you look at some of this data, you see that there are empty values. For instance, now if you look at street number, this has a lot of unit, has a lot of unit suffix. Now this is because I'm opening it in Excel, right? But if I come here and you see street number, you are seeing NaN, that's NaN. So it is seeing it as NaN, not a number. That means it's empty. So let's do let's check. That's df. Oh, sorry, I'm not using df. I'm using missing data dot info. So this will give you information about the data. So now you can see more of like, I will call it, I don't want to say comprehensive, but you're getting details about everything you have presently in that data. So you are seeing permit number 15634. I think before this you can run ship. Sorry. You can run missing data.shape to just understand how many the rows and columns you have. So when you see this and you see this, you know that, oh, it's complete. And you can see somewhere you have 160, you can see somewhere you have 179. So you see that those ones are not complete. And you can also see the objects, the ones that are integers, the ones that are numbers, the ones that are floats and texts, objects, that's objects. So you can see it also. But another thing is you're also seeing dates, and date is coming out as objects, which should not be actually. Dates also has its own format. So if you want to interact with dates properly, you would need to convert it to a date format. So there's another I think float integer object, that's 3. So there's also there's a fourth type you can convert for date. So date has its own format. It's called date time. So we'll get to that in a bit. But looking at all of this data now, you can see that here we have different types, and we've already understood this, what's the missing data that are present. Now if you now want to understand, okay, see how many, let's say let me see, hold on. So if you want to see the percentage of the data that you're missing, for instance, that would give you some insights, right? Rather than say, okay, this is just 160, you want to know the percentage of this 160 over the total number. So what you could do is you could say, hold on. So if you check the length of missing data, the length is like how many rows are there. That's 15,364. Good. Now if you want to do check missing number that not missing, right, you just do, I'm sure we've done this before, missing data dot is none. Okay, we didn't do this because we didn't have missing data actually. So if you want to see missing data, right, so you could either check is null, that's is it empty, right? So if you run this, of course it will put boolean into everything. But if you want to know the aggregation, the count, you have to add dot sum to this, dot sum. So it will sum all the truths together, and you will see it here. So you see the ones that are actually missing, how many is missing. This one tells you how many is present, that's the info. But the is not tells you how many is missing. So I think I should use comments here. So more like number of missing data, something like that. So it's telling you the number of missing data, right? So you are saying that this has the highest, I think so. Yep, no, this is the highest. You see, so the way I could not tell which is the highest, we are going to resolve that soon. So then aside this, there's also another way to check. and that is missing underscore data dot is NA. So is NA means is not available. NA is like not available, but it's also a pandas method or attributes. So also if you do the same thing for this, you get the same thing, then you have to do dot sum. Sorry. So you found out that this data here is also the same thing with this data here, because they actually work in the same way. They actually do the same thing actually. I don't think I found the difference, but it's actually the same thing. It gives you the same results. So I could just say another method to find um to find number of missing data. So this could be another method. So they both work in the same way. But remember when I said that what we want to do is to know the amount, like the percentage, that would give us an understanding. So what will happen is it's more of like we are going to be dividing all of this number by the total length. So rather than do it one by one, right, we could do it all together. So what we would just do is we would do missing underscore data, sorry, missing underscore data dot is none, is none, or let me use null. Then dot sum, they will now divide it by the length of the total data. That's missing underscore data. Remember that if you do length of missing data, you get this. So it's more like you're dividing it by the total number. You could use this number, but it's better to use all of this, like use the formula itself, how you got there, because using the number, of course using the number will work, but it's not the best practice. If you use the number, this data set can change, and the time you are loading it, you have it. For instance, now let's say I decide to use the number now, right? I'll get this. Now if this percentage, if this is no longer the total size of the number, so let's say at the size and the time I'm loading this data into this place, I've done some edits to it in my Excel. Now if I should want to reproduce this and just run all of this together, there's going to be error. So let's say my data set is now it's no longer, let's say I've reduced in size, so it's now about 15, let's say 10,000. This data will not be correct. But if I use the formula itself, which is length of missing data, so if I use the length of this, right, if I do this, it means that it will be reproducible. There won't be errors when I edit it. So let's say I've done that, I've reduced it to 10,000 and I bring it to this place, it's still going to be 10,000 here. So if I run this now, I would get this, but this is still not straightforward. It's giving us the answer. So what do? Let's multiply this by 100. So I put everything in brackets, and outside it put 100. So if I run this now, you can see the percentage easily. So you can see 100%, you can see 98.07, you can see 98.83, you can see 98.95. So this is like the percentage of missing data that is present. So it means that 98% of this data is missing in this column. In this column, it means that 86% is missing in this particular column. So you can see how it's actually coming out. You can see how you are able to tell, oh, which data is missing. So if you feel like on your own that if maybe 80% of the data is missing, I want to remove that column, I can't use it for my analysis. Or you could say 60%. I think I read an article where it was about the missing data. There was about, oh no, the article states that if your data set is at least above 60% of missing data. So that means if you have 60% of missing data, then you should drop the whole column. You should not use that column for your analysis, because it means that if you are going to be filling that data with some values, then you are you have started fabricating things. Let me I can't I don't have the English right now, sorry. So it means that you have started, probably imputing things that are not sure. That means your analysis is not going to be um guaranteed, or should I say accurate again, because you have tampered with the data, you have now edited it. So that's simply what uh, this will help you to do. So you could say, oh, okay, if my data set is already above 80%, right? Drop it. I'm going to drop it, right? If it's 1%, I can still do some things to it. So what we are now going to do now is I'm not going to drop any. Okay, I will show how to drop. There's a way to drop. So for instance, now this particular column, 100%, that means there's no data in it at all. So that means it's even completely useless to us. Now let's do something. So in this place, I know how to put everything in brackets. So usually I can do without putting this in brackets. I think I will still get this, but just to make everything understandable, right? So you can separate it and make it look nice and understandable. So it means that this divided by this first, then multiply by 100, rather than just mix everything together, right? In I know mathematics for some of us, for instance, for me, I love math, but I would love to make it complex. So there's also I'm sure most of us have heard of board mass, which is brackets up. I think I've forgotten the O. Then the D is for division. Then the M is for multiplication. Then addition and subtraction. So in programming, that's also the same rule. It applies. So which is why the divide division will work first before the multiplication, right? So I think we can just move on from there. So I think I want to be putting comments so that when we start looking at this, so more of like percentage of missing data. So what we want to do now is we want to uh, drop data that we're not going to need, right? So I'm going to copy all of this and convert it into a dictionary. So I think last week we did something about that. So I'll enclose all of this again in a parenthesis, and I will put in the end to dictionary. I think this should work. No, this one is not working. So this would work then. Yeah, so this works. So converting it to a dictionary, it means that it will take all of this. You should just take this and put it here, right? It will use the column name as the key and the value itself as the value. So which is what happened here. So you can see now every one house now has a the missing data is a column. So we can just store all of this into let's say missing dictionary, right? So I'll call this again so you can see it, missing dictionary. Now, so let's say we want to drop any data that is above should we say 60% or should we say 50%? Any ideas? Should we say 50 or 60? Or you have a better suggestion? Kingsley Olaiya Ayobami, sorry. We're not seeing anything. Percentage of data to drop will be okay. So I guess I'll just go for 60%, So let's say we are going to be dropping 60%. Good. So what we are now going to do is, so it means that we want to tick all the columns that are here. So anywhere the key is greater than, sorry, the value is greater than 60%, drop it. So we want to iterate through, we want to go through the list, through the dictionary. So to just say, for, remember our for loop, for 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 keys, right, in the range of length, that's, it's going to be starting from 0 to the, that's, if you check the length of this dictionary, for instance, this is missing dictionary. So if you check the length, so that's length of missing dictionary, you have 43. So it's going to go from 0, this range will go from 0 to 43, which means that 43 is not included. So we want to put this here, right? Or we could, should we use the data itself? Okay, let's use the data itself. So let's say for keys in missing underscore dictionary dot keys. So this is going to iterate us shortly. So we can do a test and say, okay, first of all, print keys. Let me see if I'm doing the right thing. So you can see all the keys comes out. So we can now check. Okay, so so if, so we are going to create a new list. So what we want to do is we want to store the column that is greater than 60 into another column. So let's say columns to drop, that's columns drop. So these are the columns we want to drop. We'll store them inside the list. So we are creating a new list. So if the value of each dictionary, of each keys, of each keys, so that will be dictionary missing dictionary keys. Remember the way we assess it. So if the value is greater than 60%, print it. So let's print it first. Print the keys. So you can see the keys, these are only the keys that is greater than 60%. So you go and check, you see you should see TIDF compliance. Sorry, let me take this out. I don't want this here. So you see street number suffix, units, unit suffix, right? These are the ones that are greater than structural. So everything that is greater than 60% is going to be included into this list. So what we want to do now is we want to put this into column.drop. So what we can do is, so rather than just print, we could say columns dot underscore what drop dot append. Remember how we can add to a list. So we want to append the keys, and we can also print it anyways. So when you run this now and you check what is in columns dot drop now, columns underscore drop, you are going to see this same list here. So now this is the list that we want to drop. So how do we drop it? So you now have to go back to your missing data. I don't think I have to run this. I'm just quit this. So you go back to missing underscore data, then you click on dot drop, then you pass in the columns. So the columns is already in a list, which is columns underscore drop. So we are going to put that here, and so when you run this, it is going to drop this all the data that is here. So for example now, strict number suffix, you're not going to see it here. Streets, yeah, okay, you can see you're only seeing street suffix, you're no longer seeing street number suffix again. So that data is gone already, right? So what we can do is, so this is not saved, so we need to store it back into missing data. So we are going to put it here equals to this. So anytime you now check missing data, this data, all these keys is not going to be there. So let's see. So if you check missing data now, missing underscore data dot add, or let's say dot columns. It's easier to check with columns. Oh, hold on. Okay, I think converted this to markdown. Good. So if you check this now, you're not going to see this list here again. You're not going to see it here. So this is one way to drop it faster with pandas. There are other ways. I think another way to drop it is maybe if you call the columns, you store the columns into a list, right? Then you subtract this list, this column from this column, like more of like you remove it, and you now call, you now put only these columns into missing data, like more of like saying missing underscore data, then you put in this column everything. I think I can just, let me just copy it like this. So if you copy, of course this is not, it's a very stressful way, but if you do like this you still get the same thing, but it's stressful actually. So why not just do it this simple way? So I think I can now do missing underscore data dot add. So now we have dropped the ones with larger, right, that had a lot of missing data. So now what we now we still have some things to do, because if you check info, you still see there are some missing data. I think better still, we could just take this one that we used here to check the percentage. We could just bring it back. Let me just copy everything, and I think I should replace this with it. So that will give us more information. So you can see now that the missing data has reduced, right? You now have 40, 20%, 22, 18, 20, 25, about that. So before we now start doing, let's undo one thing first. Remember that we need to convert our dates, all our dates, because they are not in the right format, right? So to do that, we are going to convert it using pandas. So pandas, remember we imported pandas as PD. So it has a function that is called to, I think if I put tab, you see to date time, right? So inside this date time, you are going to pass in the date, the column, which is I think the ones we are interested is data. Sorry, it's supposed to be missing. Remember, it's not everything we want to convert, right? So I think we can do this intelligently. So how do we do it? So let's store dates into the dates into a list, all the dates columns. So we could say this. I'm ready. There are so many ways that are running in my head right now. So this is date. So this is even doing it manually. So another thing that just came to my head is you could store all the lists in a column, then check if the word date is present inside every column. So if it is present, store it. So because this way I can miss out on some things actually. So I'm so certain I can miss out on a lot. I think when I was even checking this data, I missed out on a few things. Well, let's just go through these routes since we're only using it once. I think I'll just do the implementation so you can see how fast that one is, rather than just, the point of programming is to automate things, to do things faster. Because um if it takes you 5 hours to find a way to automate that task, right, it is actually better than using 5 minutes to complete the task if it is a manual task. Do you know why? Because when you need to redo the task, you wouldn't have to spend 5 minutes, you spend maybe 5 seconds. So if you need, imagine a case where you have to redo that task 50 times, you would not have to spend 5 minutes on all the tasks. It's just be 5 seconds, in fact milliseconds. So I think these are all the dates. I think so, actually. sorry. I want to put, okay, yeah. So these are all the dates. So if I check uh dates now, sorry, dates. Yeah, you can see all the list of dates. So these are all the dates. I think so, actually, because I did it manually. So what we want to do next now is we want to so let me show how the date time works. So I will first of all do an example. So to date time, then I'll pass in the data inside, like data. Then for instance, I think I saw filed dates. So if you do this, hold on, sorry, this is supposed to be missing data. So if you do this, it will convert it into a format that it is actually date time. For instance, now if you check this without converting it, you see it like this. And if you check the type, that's I think it is the type, you see objects. But if you check the D type for this, that's the type of, sorry, I should not put this. You see M8 NS. Okay, I think this might not really make sense. Let's put everything into bracket and just do this type. I think it's supposed to be dates. You're supposed to see dates. Okay, let's just convert it. I'll show us. So if you do this now, you are supposed to store it into date time, but we want to automate, we want to do it once. We don't want to write 5 lines of code repeatedly. So what we are going to do is we are going to use a for loop again. So this time around, we are going to say, let me clean all of this. So say for dates in dates. So I think I should name this, put this in capital letter, so that it's not cause confusion. So it will be for dates in dates. So what do we want to do? Okay, let's print dates first. Right, that's like the first thing to do. Oh, sorry. So you can see all the dates is here, right? So that means it's coming out. So for dates in dates, so what we want to do is we want to um put missing data and dates. We want to store it into, or first of all, we want to convert it to pandas date time. Then we'll do pd dot to, I think you can see it to date time like this. Then you want to store it back into this. So it's like you want to store it back into this. So you just take this and put it here. So when you have it like this and you run it now, so if you go back to go and check missing data .info, so you're going to find out that your date time is now in date time. You're not seeing it as objects. So it means that you can interact with it with date. You can do subtraction between the days, between the two dates, to get the difference in days, right? So all those things are now made possible. Then we've still not handled the actual missing data that we have, right? So let's go into that now. So missing underscore, I think I should just go and copy it since I've written it before. Here is it. So let me just paste it here. Good. So let's start from street.suffix, right? Uh so we are going to have missing. So it's like we want to go through a step by step of handling it. So it's missing data, then we have street underscore suffix. So first of all, we want to see what the data looks like. I think I pressed the wrong thing. I think yes, everything is in capital letters. and there's no underscore. Yeah, so it looks like this. So one of the ways you can fill in um the missing data, because if you check the sum, so if you write is NA for this and you put dot sum, you still get, you see the number of missing data that are there. So one way you could fill it is you could fill in your data by either mean. So there you can fill missing data with the mean. So mean happens to be average, and it works when you're dealing with um columns that are actually numbers, either integer or floats. So you can fill it with the mean. So it's do the summation, then do the average. So mean is average basically. So you can do with mean, or you can do with median. So median is like is not is I wouldn't call median average. So median is like the middle number. So if you have um so if the list of numbers that you have is like 0 to, for instance, now if you look at the rating of an hotel, there's 1 star, there's 2 star, there's 3 star, there's 4, there's 5. So that's like an ordinal data, because the category, each number means a particular thing. So in that situation, the median is 3, because 3 is the middle number, right? But in a situation where you have different kind of numbers, 0, 0.5, if you do the median number, it will not really work. It won't make any sense. Then the last one is modes. I wouldn't say the last one, but it's like the basics. So the mode is like you want to get the most occurring. So this is more useful with text data, right? The data that is occurring the most. That's where this comes in. So you can use it. Of course, there are other methods. There's forward filling, there's backward filling, but that's like advancing if you want to start filling missing data, right? And I think those ones are more applicable when you're dealing with time series. So we are going to be using these three: mean, median, and modes, right, to fill in the data. So from what we understood that missing data, this particular one, is more of like a categorical data. So let's see how many, or the objects that are in it basically. So to do that, we will call unique. I think I mentioned this last class. There's values dot count. This will count the unique values and tell you the number. So you can see here that street here is having this, average here is having, AV is having this. I think it's avenue. I don't know what the rest is. I think LN means lane. I think CR means crescent. I don't know what the rest means actually. So to now do this, you could decide, do you want to use mode? Of course, mode is the only thing that looks like. And if you are going to get the mode, of course, you can see here that ST is the mode. But remember, we don't want to be doing this manually. I could just say, okay, mode is equals to ST, right? But I don't want to do this manually. So the way to do it is to get the missing data and just put dot mode. Then you can see the mode here is street. So we need this mode. So what we do is we want to get the string. So if you put 0, 0 will get the string. So we can now store this into, let's say, mode street suffix. So this will now hold the value for mode st. So this is what we want to now use to replace the missing data for mode for street suffix. So how do we now go about it? So what we are going to do is we'll still need to call this. So just like we have is NA is NA, right? We also have fill NA. So fill NA means fill the non-available, like the non-available in this particular data. And what do you want to fill it with? We want to fill it with the mode, which is this. So we just put it here. And so if you run this now, of course you won't be able to tell whether it has been filled or not. So what you could now do is you can store this back into because when you fill it, you want to store it back into this place. So you just do this, um, or rather than do this, I think this elongates the code. So I think there's a method into fill any that is called in place equals true. So let me check if this is actually something. Yes, so there's in place actually. So in place means that I want to do this immediately inside data. I don't want to reassign. I want to do this on the data. So it's going to save everything you are doing back into this place automatically. So let's do that now. Then let's check. Let's see if it has actually worked. So what we are going to do is we are going to run this again. I'll bring it down. I'll run it now. Then you see 0. So it's no longer 194. It is now 0. So if you check this value count now, you find that ST is no longer 10,944. So if I run this now, you see that it's now 11,135. So that means it has handled the missing data has been added to that place. So that's how we have handled it. So we didn't have to drop it, we just had to fill it in. So that's like describing how to fill in with this. I think I should move. This should not be here. Can I move it? No. I was trying to discuss. I think I should put it here. Yeah, let me just put it here. Good. So let's now move on. So now we've handled an object data. So let me shift to another kind of data. So let's say let me go back. Where do I have my missing data? So this is where I run the percentage. So I held this. So let's say I don't want to deal with the date yet. Okay, good. Let's say a number of existing stories, right? Is a missing data. So I'm copying this, then missing underscore data, then run this, then run is NE, right? Just to know how many is missing actually. Not really. We know it's missing, but we just want to have an overview. So we have 3,000 about this. They want to see, of course, we know that is okay. I don't want to assume or say it like I know. So if you do dot add, will this even work? I don't think dot add will work. So you can see that it's a text, is a number, and is a float. That's a numerical column. So what do we want to do to this now? we It will make sense to run values count, because values count means like it is unique. It means different things, right? Number of existing story means that okay, there's just an existing story. So what we are going to use, we can't use mode, neither can we use median. So what is best to use here is the mean. So I'm going to be doing, so to get the mean, all you have to do is do dot mean, and it will give you the mean. So this is the mean of the data, but you can't use 5.376 da, da, da. All we can see here is 6 point something, everything is 0. So it has been rounded off to the whole number, nearest whole number. I think that's what it's called. So we will need to round this off too, or round it up. So to do that, we can, so there's a method called round in Python. So if I put round now, you can see that it's a special number. So if I put 4.5 into this, it's rounded to 4. You can see that. So that's what we are going to use now. So we just put everything here into what? Round, sorry, into round. Then you round it to 5. So I think if it's 4.6, it will take it up. I'm not sure. Yes, let's take it up to 5. So like nearest whole number basically. So this is what we want to store. So we store it like mean of mean of existing stories equals to this, right? So if you check this now, it's still going to be the same thing. So you have 5. So this is what we want to now use to fill it. So just like we did for this, that's what we are going to do for this too. So we are going to call missing data dot what dot fill NA. and we are going to pass mean of where you start mean of sorry existing stories, right, into this place. Then don't forget you have to use your in place if you want it to save the changes equals to true. So these are saved. So if you now go back to check this, you find out you have 0. So it has fixed that. So I think I've done with okay, so I don't really think we have a categorical data, no, an ordinal data here. I think what we have here is description. So in cases like this where you have, for instance, I think there's a, for instance, now if you look at this description now, if you check the contents, right, description here is basically like so data description, sorry, I did this again. So it's more of like a text data, right? So in this kind of situation, I wouldn't say you should fill it with the mode or the mean or the median. So what I could just say is you could fill in. So if I check the number of ones that are missing now is NA dot sum. You find out here they are about 25. So what we could just do is we could try to fill it with the mode, or we could try to fill it with something different. That's more like unknown with a text. So you just have to say, so I'm decided to fill it with a text. I don't want to fill it with mode because I already explained the mode earlier. So I just want to demonstrate another example. So I'll say fill NA. So what I want to fill it now is with a text. So the text is unknown or not available. Not available. Then don't forget in place equals true. So if you go back to now check this, you see that it's 0. So that's also another way to fill. So basically it just depends on what you want to fill it, what you want to fill your missing data with. I think we've handled almost all the type of data that you could see, right? For instance now, I think this existing construction type is more of like a median kind of ordinal data. So if you check it, missing underscore data, so you can see it has, I think it's just from 1 to 5. So if I call unique QUE, okay, hold on, let me use values underscore counts here. Okay, good. So you can see here we have just 1 to 5. So I think it's safe to use the median here. So what we can now do is we would need the median, which is 3. So let's do this. Bring it here. Dot what? Median. No. Oh, okay, sorry. The median here is 5. Okay, I could explain that. It means that it has arranged it's not looking for the middle values. Like, I think, I don't know if I explained the median very well. So it's like it takes all the numbers, then pick the one that is in the middle, like it divides the number into 2. So if you divide all of this into 2, 5, it will still take 50% of this data is, let's say 50%. I think about 70% of all of this data is 5. So basically that's what the median does actually. So if you, in this situation, if you check the mode will be 5. Because also that's what is appearing the most. So you check the mode here is also 5. Though you can't check the mean. Oh yeah, I think you can also check the mean because it's also it's a number representing something, but it's still a number. So if you check the mean, you're having like 4 point something, though it will not give you 5. But the emphasis was supposed to be median. So we can store this inside median underscore existing construction construction. Let me just put it here, right? Then I would now go ahead to call this and fill it in. Dot fill, as usual, fill NA with what? The median. I think eating tab will give me this. Then don't forget again, in place equals to what? True. So if you go ahead to check, you find out that your missing data is no longer there again. That's what is NA, right? Yeah, dot sum. So it's now 0. So basically that's just an insight on how you can undo all your missing data, right? How you can clean it up. Sometimes it might even be that the NA, I was actually hoping to see some empty values, right? Where okay, so let me use supervisor district for instance now. So in a situation where I'm going to do something here, so I will undo this missing data. So I want to replace, in a situation where you want to replace something, right? If I do value underscore underscore count, I think you can see the supervisor districts actually is numbers too. Okay, but there's NA there. So what I'm going to do now is I want to replace the NA, because if you check is NA dot sum, you still find missing values here because it came under our list. So there's about 109. So let's change all of the NA where we have NAN. So that will be dot replace. So that will be dot replace. And in dot replace, you will need what you want to change and what you want to change it to. So for instance, now I want to change where we have NAN, right? That's actually is np.nan to missing. So this is what I want to change it to. So I want to change it to this. So if I run this now, and I don't know if it has in place command, so let me check. Okay, yeah, it does have in place. So I want to do it to in place. So I don't want to have to rename in place equals to true. Now if you come back and check if we have missing data in this dot is NA dot sum, you are going to get 0. But the truth of the matter is there's actually missing data inside of this. I think I made a mistake. I actually did not want to change it to missing. I want to change it to an empty value. So what I would do is I would bring it back here. I'll replace it back to NAN. So that if you run this, you still have this. Then I will now change this back to, yeah, so yes, I'll leave it like this. Good. So now the point I was trying to describe is there can be some data where there is actually nothing inside. It can be an empty string, which is what I want to describe. So it's possible that it's an empty string. If you run missing data is NA, it's not going to work. The only thing it's going to catch is when it is just in this format. That's NA and like this. That's the result of np.na. So if I put nan, the result is nan. That's not a number. So it won't catch it. So sometimes you need to actually look at it, look at the head of your data, look at the tail, for instance, df dot, sorry, more of like missing underscore data dot tail, right? To see, okay, what's going on in the tail, what's going on in the head. Sometimes you don't actually know, right? So in that situation, what you need to do is, you need to write in some things like, you want to see, oh, what are the unique numbers that are there? Sorry, hold on. Sorry, it's not complete. Yeah, so you want to see some of the missing numbers, that all the numbers are there. So if you look at this thing now, you see you have 3.06, 10, 5, 8, 2, 9, 4, 1, 7, 11, and empty. So these are ways you now determine, oh, I have this data, I should not have this, I should not have empty. So in this situation where you have empty, that's when you now want to replace it with np dot nan. That's where this comes in place. Normally I had to just fabricate this. There are some data that I like that I've dealt with them before, that this was what was there. It was an empty. Some was just NA, some was not available, some was N slash A in capital letters. So more of like this, N slash A, some were NA, right? I think some were even in small letters. So this way you wouldn't know. So these are things to watch out for when you are dealing with data that is missing, that is incomplete. There's also the aspect of inconsistent. That one you need to, that's where this will also come in place, replace. So that when you observe it and you see an inconsistent data, for instance, let's say, okay, let me fix this, then I'll explain that. So to fix this now, all you have to do is just say, you take your missing data, then you do replace. So what you want to replace is the empty one. You want to replace with np dot nan, so that if you convert this in place equals to true. So if you convert this in place and you go back to check dot is na dot sum, you are going to see that, oh, okay, now there's now missing data. You can now go ahead to handle it. So in case you want to do it in general way. So these are also things you should watch out for. Now the other one I wanted to mention about is like when you have an inconsistent data. So let me come here, let me look for an object data, for instance, and by the way, you are supposed to get a dictionary, like a dictionary that explains that tells you the meaning of all these columns actually. So missing underscore data, then I should have this. Okay, good. Then I want to check the value underscore counts. Good. So I have this. So what I'm going to do now is I'm going to change this. I'm going to change one of this to capital letter F. So what I'm just going to do is I'm going to take this. I'll get maybe any one. So let me say I want to get the first one. 0. Okay, this first one is none. So let's say I want to get the third one. That's number 4. No, I'm interested in the one with index 3. Good. So I'm going to change this to wood frame. The frame is in capital letter, and I'll put everything else will be the same thing. So let's see what happens. Hold on. Yeah, I think I've done this already. So it's successful already. So let's go back and check this here. Now you are going to see wood frame 5 1, wood frame 5 806.40, whereas they are actually the same thing. But what happened? Maybe when they were inputting the data, someone decided to use capital letter F, and yeah, everybody was using small letter F. So these are where you deal with inconsistent data. I think the other data that's here, that's this inconsistent data, has a lot of data like that. So if I check, okay, so let's just check it real quick. I think which particular data is like that. I think let's check the blast date type. So so blasts D, take this capital letter D, then type sorry, dots, I could do dots unique or dot values count. I think the unique will be faster. So you can see here we have holiday, working day. No, this doesn't have. Let me see again. There's one in particular that has it. Not holiday type. Um, let me see. Okay, let me just check the column. That'll be faster. Dot columns. Okay, yes. So let me see. Okay, I think this. Yes. So let's scroll down. Nope. I didn't want this, but nevertheless, I can still work with you. And inconsistent underscore data. Then check the unique. So if you check the unique here, you see that there's open, there's small letter open, there's close, and there's capital letter C with close. So this is a big issue. You can't do your analysis because all of this will be classified or categorized separately. So you need to resolve this. So to resolve this, all you have to do is decide, do you want to use the one with capital letter or small letter? So it looks like the one with capital letter is the one that is. So we are going to replace all the small letter with capital letter. So all you have to do is just do this, dot replace. What do you want to replace? The small letter. Open with what? The capital letter. Open. So before I replace it, let me just do a value count so we can see that work. I made a mistake. So you can see here. So let me work on it. So you can even see here that this open has little, this close also low. That means it's supposed to be capital letter open and small letter close. So I also do this in place equals true. But I would like to do the other one too together. So I'll just copy this and paste it here, then change this open to small letter close. Then I'll change uh this, I think it's closed. Yes, closed. Then I'll change this to capital letter closed. So if you run this now, I come back to run this up here, down here. Of course, if I run it up here to change, but I don't want it to change. So if you run it here, you see that it has reduced and it is now uniform. So this is how you actually undo it is inconsistent. So these are like basic simple ways you can actually clean your data in Python. These are possible, like I said, they are possible in Excel. You can use your find and replace to do it. But you see, I like, for me, I'm more of into automations. I'll prefer to automate it so that if I come back to this, I can just rerun it and it reruns everything for me. So which is why I love doing it this way. Actually, if you ask me to do data analysis for you, I'll do it with Python straight up because I can reproduce my results easily. So this is how you can actually handle. There are numerous ways, but these are all I've done today are just the basic and the simple ways to actually um, handle missing data. Just basically to clean your data, right? Um, make it ready for visualization. So now is if you now want to decide that okay, well, I'm done with cleaning my data, I can now take this. I want to go and do my visualization with Power BI. You can do that because Power BI, of course, it's a visualization tool. It's specifically for visualization only, which is why visualization is easier on it. So you can decide to do that. So I'm just giving us an insight into what the project is going to look like. The project is going to be, I think, I want us to do one full. So I have a particular data set I'm going to perform a data analysis on from start to finish with Python. But the project is going to be more of you take your data, you clean it, then you can clean with Python. Like I said, you're going to be using about three tools, right? So you could decide that okay, you want to go to SQL. For instance, if you remember the Instagram data we had like about I think 5 different CSV files. So you can decide to merge everything with SQL, then come to Pandas or come to Python to clean it, then take it to Power BI to visualize, right? Or you could go to take it to Excel to clean, right? And just make sure that the point is you are going to have to make use of those three tools effectively for all the single projects you are going to work on. So that's the goal. That's how I intend. I'm still drafting the reports. I'm still drafting how it's going to look like, but that's more of like the shape is going to actually form. It's going to take. So basically, so what we have basically done today, if I'm just remember we started from loading our data into Excel sheets, right? Finding the difference where you can do it because our sheet had two data, so we had to learn how to load the specific one we want. Then we decided to I think we started from checking the missing number, the ones that are missing. Then we checked the percentage of data that are missing. They decided to drop the ones that are larger than 60%, right, using a for loop here. Then I think we then move on to we converted the dates into date time. So for the dates, if you want to um fill in dates, for instance, for me, I don't like filling dates. So if you want to fill in, I think the best thing to use is the mode, the one that is most occurring, or you could actually use the median. But I wouldn't say median. Actually, it all depends on the particular tax, right? The kind of dates that you have. So there's no one straight way to do that. And we went on to start filling. So we filled in our our object data, which is categorical data with the mode, right? Then we also checked out to fill in with the mean, right? We also learned something which is round up, so we can use round to round up our values from float to integers. I think you can also use integers here. So if you use int, it will also put it and convert it into an integer. But it's more of like I think round actually makes more sense, like you're rounding it up. Then we tried to fill in with mean. Then we also did we did fill in with actual text. So if you want to fill in with the text, right, you could fill in with the text. Then we went on to try out with the median too, and all of this was in place. So we used the in place method. So some of not every all the functions have in place. So I also explained how to check it, which is just click on this, then hold shift and press tab. Hold on, wait. Okay, you just have to click on it, make sure your cursor is on it, then hold shift, then press tab once, press it again, it expands, right? And you can scroll down to see some of the things that you can take. So if you can take in place, you see it here. So not all of them takes in place. For instance, I think is NA does not have in place. Sorry, you're not going to see in place there, right? So because there's no even need to be in place. So we replaced. So we also understood when your data are missing an empty value is empty. There's nothing there. It's not numpy, not a number that is there. It is just empty with an empty string. So you also see how you can check and see if your data has that kind of thing, and how you can remove it or replace it with something else. So we did a bit of handling inconsistent data. So if your data is inconsistent, right, that you have data that are different, right, you can also do that. You can use the replace method, that's replace, to replace what you want to replace and what uh what you are replacing and what you are replacing it with. So which is what we did here, and I think that's basically what we did. So next class should be the last class for Python. I think we have come this far, and uh, we'll see. I'm thinking maybe we could do a makeup class, but we'll talk about that on the group, or we'll just do it on a Saturday. when everybody will be around. So I would like to stop here for today.